Okay guys, so today we have lesson 7-8 where we are going to be solving cube root equations and inequalities. This part, the inequalities part, we're actually not going to be looking at today just because of time. I want to make sure that I keep these videos 10 to 15 minutes long and not overwhelm you with the information that I'm giving you. So we're actually going to continue with this lesson tomorrow, and we're going to be talking about problems that have inequalities. So don't freak out if you don't see inequalities today. We're going to be doing that tomorrow. Okay, so that's the do not question. I will be talking about the do not question tomorrow in class just to review it. Actually, no. I'll talk about it at the end of class. Okay, so for today's lesson, we are going to be solving cube root equations. The inequalities, we'll do that one tomorrow, okay? But before we do continue with this lesson, I do want to go ahead and talk to you about all of these things that I have here on the right side of my screen, okay? So when we're going to be doing this, when they ask us to solve or to find a solution, right? So we can either solve or be finding a solution. What they're telling us that they want us to do here is that they want us to find the variable, right? They want us to be finding a variable. What variable is that going to be? It's going to be the variable x, right? So that AKA solving for x, right? So what that means is that when we're solving for x, once again, we are going to fall back on SWBAT, okay? That is what we're going to be using to solve these problems. So SWBAT keeps on popping up right here, okay? Here are a couple of steps to kind of like help guide you in how to do these problems. First thing we want to do is we want to analyze the given information. Second thing, once we analyze, we want to solve, right? What are we solving for? X. How are we going to solve for x? Using SWBAT, okay? Third thing is to check our answer. How are we going to check our answer? By plugging it into the original equation. That's also something that we've done before in the past, so it should not be new. Just make sure that you can identify what the original equation was. Okay, so we have our first problem here that is saying what is the solution? So again, keyword right here, solution, meaning solving for x to the equation. Okay, well, what's the equation, you ask? The equation is going to be the cube root of 5x minus 1 equals 4. Okay, so we're going to go ahead. We are going to solve for x, right? Solve for x. How? Using SWBAT. Okay, so I'm going to go ahead and I'm going to write SWBAT here on the side to help guide me with solving this problem. If you're ever at lost, guys, literally just use SWBAT. It tells you what to do. So I'm going to see, do I have subtraction? Well, yes, I do, but the subtraction is inside the radical, so I cannot do anything with that right now. Do I have addition? I don't see a plus anywhere. Do I have division? I don't see a fraction anywhere. Do I have multiplication? I do see a multiplication, and it's with this 5x right here. But once again, that 5x is inside of the radical, so I cannot do anything with it. So I can't do anything with that, so I'm going to skip that. Now we have exponents. Well, like I told you guys yesterday, when you're at the exponent, you can also think about this as a radical, okay, because we're dealing with exponents and radicals. Well, what can I do here is that I can go ahead and get rid of it, right, by using the exponential property, right, or the exponential rule, that if I have a cubed root and I want to get rid of this because it has an index of 3, is that I can go ahead and raise it to the power of 3, right? So just look at the index, and whatever the index is, raise it to that power. And then obviously what you do to one side, you do to the other. So now that how did that become 0? I don't know. Okay, so now what you do to one side, you do to the other. This right here cancels out. So now I'm going to be left with 5x minus 1 equals 4 to the power of 3. Well, what's 4 to the power of 3? That means you're going to get 4 times 4 times 4. So what's 4 times 4? 16. 16 times 4, 64. If you need to do the math on the side to figure that out, please do so. Okay, so now that I have that, okay, do I have parentheses? No, I do not. Okay, so now I'm going to go ahead and continue and start at the very top again. So now, do I have subtraction? Yes, I do. Is that in a radical? No. Can I go ahead and deal with it? Yes. So what's the opposite of subtraction? Addition. I add that 1. What I do to one side, I do to the other, always. Therefore, this cancels out, leaving me with 5x equals to 64 plus 1 is 65. Next thing after that is going to be addition. No. Division, no. Multiplication, yes. Well, you may ask, where is this multiplication happening? Between the 5 and the x, right? So they never write it, but this actually means that they're multiplying. So the opposite of multiplication would be division. What you do to one side, you do to the other. X is now going to equal to 13 because 65 divided by 5 is 13. And that right there is my answer. Now, I do need to make sure that this is my answer, so I'm going to go ahead and go to step 3, which is telling me to check my answer using the original equation. What was the original equation? It was this whole shebang bang right here. So I'm going to go ahead and I'm going to check my answer, okay, using the original equation, which is the cube root of 5x, but now instead of putting x, I'm going to put this one right here. So 5 times 13 minus 1 equals to 4. Well, what's 5 times 13? Well, 5 times 13 has to give me this number right here, so it's going to be 65. So I'm going to get the cube root of 65 minus 1 equals to 4. What's 65 minus 1? 64. Well, what's the cube root of 64? Well, we kind of did this here. 1, 2, 3 gives me 64, so my answer is going to be 4. So the cube root of 64 is going to be 4. Does 4 equal to 4? Yes, so therefore this right here is a true statement. So therefore x equals to 13 is definitely 100% my answer. Okay, and so that right there is how you do this problem. I have some more examples for you, so let's go ahead and continue. Okay, so let's go ahead and do example number 2. Now, if you notice in example number 2, there's something a little bit different. We have this minus 5, and then we have this 4 up here in the front. Okay, so in order for you guys to solve this problem, you need to make sure that you isolate the radical. Okay, isolate the radical. But if we're doing SWBAT is kind of already going to tell us to do that anyways. Okay, so I'm going to go ahead and see, do I have subtraction? Yes, I do. Is that subtraction inside the radical? Heck no. So can I do something with it right now? Yes, I can. I don't know why my pen keeps on making zeros. That should be a 3. So I'm going to go ahead. I'm going to do the opposite of subtraction, and that means addition. Okay. These two cancel out. So now you're going to have 4 cube root of 2x minus 1 equals to 3 plus 5, which is now going to be 8. Okay, do I have addition? No. Do I have division? No. Do I have multiplication? Yes. Okay, where's this multiplication? Right here. Okay, this 4 is actually being multiplied times the cube root. So you go ahead and do the opposite of multiplying by 4, which would be dividing by 4. What you do to one side again, you do to the other. These cancel out, leaving me with the cube root of 2x minus 1 equaling 8 divided by 4, which is going to be 2. Okay, once again, exponent, same thing as a radical. So do I have a radical? Yes. Well, what's the opposite of a radical? A power of 3. These cancel out. What you do to one side, you do to the other. So now you're going to be left with 2x minus 1 equals 2 to the power of 3, which is 2 times 2 times 2. Well, what's 2 times 2? 4 times 2 is 8. So 2x minus 1 equals to 8. And so now we continue with the process again. Do I have parentheses? No. Do I have subtraction? Yes, again. So I add the 1. What's 8 plus 1? It is 9. and then you have 2x. Okay, divide by 2, divide by 2. X is going to be 9 over 2. Now, I'm running out of space and time, guys, but you could go ahead and just check that by plugging it back into the original equation, and you're going to see that it's a true statement because we did our math correctly. Okay, guys? Now, example number 3 is a little bit different. And if you guys haven't noticed, we have 2 radicals, and they're on both sides. The previous examples that we had only had 1. Now this one has 2. Okay, now we're still going to use SWBAT to solve this. Okay, SWBAT is literally going to tell us what to do. So if you're ever lost and don't know what to do, once again, I stand by it, use SWBAT. Okay, do I have subtraction? Yes, but it's inside the radical, so I can't do anything. Addition, no. Division, no. Multiplication, no. Exponents and radicals? Yes, I do. In fact, I have 2. So how do I get rid of a radical? Raising it to the power, right? So I'm going to go ahead and get rid of this one and raise it to the power of 3. But like we said before, what we do to one side, we have to do to the other. So now if you look at these perfectly cancel out. Okay, so now that means that you're actually done with radicals. You actually don't have any more radicals to deal with. So now you're going to have x minus 5 equals 7 minus x. Okay, and then we continue with the process again. Parentheses, no. Subtraction, yes. Okay, you can subtract whatever you want. I'm going to go ahead and I'm going to subtract the x because I don't like to have negative x's. So I'm going to add the x to both sides. These right here are going to cancel out. So now you have x plus x, which is 2x minus 5 equals to 7. Okay, do I have addition? No, you can go on, but I do have another subtraction, so I'm going to go ahead and I'm going to add this to the other side. So now you're going to get 2x equals 5 plus 7, which is 12. Divide by 2, divide by 2. X is now going to equal to 6. You can go ahead, plug that into the original equation, and you'll see that it's going to give you a true statement. So let's go ahead and check this one out real quick. Okay, so I'm going to use the original equation, which is the cube root of x, but now x is going to be 6. So 6 minus 5 equals to the cube root of 7 minus 6. What was 6 minus 5? It is 1. What is 7 minus 6? It is 1. So is the cube root of 1 equal to the cube root of 1? Yes, or you can even do the cube root of 1, which is just 1 equals to 1. So is this a true statement? Yes, it is a true statement. So therefore, x equals to 6 is my answer because I got a true statement. Okay? And so now let's go ahead and do the last example. Okay, last example right here. So now this one looks a little bit different from the other one, just because I now don't have, I don't have radicals, but I do have exponents. Not only that, I have 2 of them, so it's kind of like I have 2 expressions in one equation. Okay, but once again, don't freak out, because what is going to help us solve this problem, it is going to be SWBAT. Okay, so I'm going to go ahead and work with SWBAT. Do I have subtraction? Yes, I do. Is this inside of a radical? No, if you notice, or inside of parentheses. This is not. This is outside of the parentheses. So I'm going to go ahead and I'm going to add, well, what am I going to add? Literally this whole thing. So I'm going to add 6x minus 4 to the power of 3/4. And then what I do to one side of the equal sign, this is my equal sign, I have to do it on the other side. So plus 6x minus 4 raised to the power of 3/4. Okay? This right here is going to cancel out. So now I'm going to have 5x plus 2 raised to the power of 3/4. This is going to equal to parentheses 6x minus 4 raised to the power of 3/4. Okay? Do I have addition? Yes, but it's inside parentheses. Division? No. Multiplication? Yes, but it's inside parentheses. Exponents / radicals? Yes, I do. Okay? Now you might ask yourself, okay, how am I going to get rid of this power of 3/4, right? Well, there's also another little trick where you can go ahead and multiply it times the reciprocal and raise it to the exponent as well. So I would go ahead and raise this to the power of 4/3, and what I do to one side, I would do to the other as well. 4/3. Now what happens here is that this and this cancel out, this and this are going to cancel out, leaving you with 5x plus 2 equals to 6x minus 4. So now I'm going to go ahead, I'm going to add this 4 over here, add this 4 over here. I'm going to get 2 plus 4, which is 6, equals to 6x. Bring down the 5, so 5x plus 6. I'm going to go ahead and I'm going to subtract the 5x, bring down the 5, so 5x plus 6. I'm going to go ahead and I'm going to subtract the 5x, subtract the 5x. Okay, so now I'm going to get 6 equals 2x. And that right there is my answer. You guys can go ahead and check it by plugging it into the original equation. But that is the end of today's lesson.